Problem number 3, slightly more complex. So we begin by counting up the number of unique variables. And problem number 3, there are 2 unique variables. 2 appearances, obviously, of S, and likewise 2 appearances of R. So we take that number, the number of unique variables, and plug it into our formula to get L, the number of lines in our truth table. 2 to the power, in this case of 2, is 4. So there are 4 lines in our truth table. Take that number 4 and divide by 2. 4 divided by 2 is 2, and so we start with 2 consecutive t's on the far left-hand side, underneath our very first variable, followed by 2 consecutive f's. 4 lines in our truth table, 4 divided by 2 is 2. So again, we start with 2 consecutive t's, followed by 2 consecutive f's to complete all 4 lines. And that gives us the definition of our first variable, s. Once you've defined s, define it the exact same way every single time it appears. So one more appearance of s to go, and I'll repeat that exact same pattern underneath this second appearance of s. T, T, F, F. That only leaves us now with the r's to define. And defining our first variable, moving again from left to right, we started with 2 consecutive t's. So take that number 2 and divide it by 2. Just half it one more time. 2 divided by 2, of course, is 1. So in defining our second variable, we start with a single t followed by a single f, and repeat that pattern until we fill up all 4 lines. So one more time in this case. TF, TF, all the way down. That now leaves us with one more appearance of R. Once you've defined a variable, define it the exact same way. So I'll repeat that pattern underneath the last appearance of R, and now we'll complete our truth table. We've now defined all the variables that appear. From here, we just need to simply solve for our operators. Be sure to solve the main logical operator last. So we need to solve for the left-hand side and then for the right-hand side. Doesn't matter the order that you do this. I'll choose to work from left to right and further working vertically as opposed to horizontally. So T horseshoe T is true, T horseshoe F, that's our special case, false. F horseshoe whatever, doesn't matter the value of the second one, F horseshoe whatever turns out to be true, and the same here for line number 4. So that's our first conjunct. Now on to the second one. The main operator in the second conjunct, of course, is the dot, so I need to solve the tilde first. If R is true, not R is false. If R is false, not R is true. T becomes F, F becomes T. Now I can take care of the dot, the main operator of the second conjunct. T and F, T dot F, comparing now this column to this column. And if you find it helpful to make these little guide marks, just to keep track of where you are in the problem, by all means do so. T and F, that's of course false. T and T, true. F and F, false. F and anything doesn't really matter. F and T, in this case, turns out to be false. Now we just need to simply solve for our main logical operator, the dot. To do so, we compare the main logical operator of the left side, the horseshoe, to the main logical operator of the right side, the column we've just now completed. So T and F, that of course is false. F and T, that's false. T and F, false once again. T and F, false. Circle the column underneath the main logical operator, and now we just need to simply apply the vocab. Is it tautologous, self-contradictory, or contingent? Well, the column under our main logical operator consists entirely of f's, so it's self-contradictory. And that really is all there is to it.